Oh, don't clap yet. I haven't done anything. So I'm Pablos, and do we have any other hackers here today? No? I've got a zillion things I want to show you, so I'm going to talk really fast, and hopefully along the way we'll learn some stuff. So first of all, see if you can find yourself on this chart. So this is the history of humans on planet Earth. Not very many of us. About 160,000 years ago, you get the first Homo sapiens, but then it's just thousands, hundreds of thousands, millions, and not until the last couple hundred years did we hit that hockey stick growth curve and go from millions to billions, almost overnight. And it's that curve that defines everything we're experiencing in the world today. Well, what happened? Well, what happened is along the way, we solved some of the hard technical problems that kept humans from thriving, right? How do you feed all those people? Give them jobs, give them homes, eradicate the diseases that are killing us off, right? And the way we did that is we invented a new technology and brought it into the world, right? But if there's one thing all these extra humans are good for, it's making more problems. So our job is to figure out how are we going to scale up our ability to invent solutions on that scale. That's the job. It's hard. We have all these additional humans and no additional planets. So it's a big challenge, and that's what humans are working on here. So I thought one of the possible things that might be worth doing is see if we could get onto some other planets. So I helped start this company called Blue Origin for Jeff Bezos. It's the first time in human history that private individuals have been wealthy enough to try and go explore space. You know, before we had to have governments do it. Thanks. So, you know, we might have 1 million years or so to figure out how to make this work, but maybe we should get started. This is an old buddy of mine named Sammy. So Sammy's kind of a famous computer hacker. He got into a little bit of trouble for writing a computer virus that he was using to meet girls on the internet, which is not the way to do it, just letting you know. Sammy wasn't allowed to use computers for a few years, but he's back now. And he's been playing with Google Maps. You guys use Google Maps, right? You know how Google knows how to color the roads for traffic? Your phones are all just telling Google when you're stuck in traffic. Well, Sammy figured out that he can just lie to Google, and all the roads he's about to drive on clear out. I guess I better hang out on this side of the stage so my clicker works. Maybe that's the problem. That'd be a pretty cool app to have, though, right? Oops, let's go back. Well, we can stay here. I'm clicking too much. Hackers like Sammy have different brains than a lot of your friends, right? They're a little bit deranged. But they're good at something important, which is figuring out what is possible, discovering what's possible. If you get a new gadget and show it to your mom, well, she might ask you, what does this do? And you can explain, it's a phone, Mom, iPhone. It says on the box. But if you get a new gadget and give it to Sammy, well, the question is different. The question is, what can I make this do? He's going to flip it over, take out all the screws, break it into a lot of little pieces, but then figure out what can be built from the rubble. And it's that discovery process that's fundamental to invention. It's fundamental to innovation. Without it, you never get anything new. Nobody's ever invented a new technology by reading the directions. These are the guys violating the warranty before they got the shrink wrap off, right? We need them. I'm not saying you want to hire them, but well, it might be a little risky, but we need them because that's where these superpowers come from. So this is a protocol diagram, which is probably the most boring slide I hope you'll see at this conference. you can actually ignore this. But this is a protocol for the encryption system in your web browser when you're sending passwords or credit card numbers to Amazon or anyone else. What hackers will do is attack every point in this protocol. What happens if I send 2 responses when I'm only supposed to send 1 to the server? Or what happens if I send a 0 when I'm supposed to send a 1? It might break. And if I can get it to break, maybe I can get it to do something it's not supposed to do. Like give me your password. So let's, next slide. So this is Anopheles stephensi. It's a female mosquito carrying malaria in sub-Saharan Africa. And this is the most dangerous animal on Earth. Not sharks, not snakes, not spiders. Actually, the person sitting to your left or your right, watch out for them. Whoops. Oh boy, I'm having problems. Back up. All right. This is the low-hanging fruit in global health right now, right? Almost 1 million lives a year are lost to disease spread by mosquitoes. And we can solve that, right? This is a protocol diagram for malaria. It spends some of its life in a mosquito, some of its life in a human. It's super complicated. We don't understand that much about how it works. So what we do in the lab that I started is we hire hackers to attack every point in this protocol. We can and will eradicate malaria once and for all in our lifetime, but not by reading the directions. There are none. We have to invent new tools for the arsenal. This is the old-fashioned way of going after malaria. You spray chemicals to kill everything, and then you hope the good stuff comes back. So this is actually how we got rid of malaria in the Southwest, in the US, and in Southern Europe. This is a real ad from like the 40s. Teach your kids to sing DDT is good for me. It's not really good for you. But that was the best technology we had at the time, right? So when you're an inventor, you always try to invent a solution involving lasers because lasers are cool. So we thought, what if we could find the mosquitoes and shoot them down with laser beams? So we laughed about it for a bit. I hired a hacker. He bought some consumer electronics on eBay. 6 weeks later, using motion detection algorithms, we're tracking live mosquitoes. So what happens is if there's something moving, we aim a laser at the moving thing, and we use that to sample their wing beat frequency. And from that, we can tell it's a bug, it's a mosquito, the species, and the gender. So if it's a female Anopheles stephensi, well, then we can shoot it down with a lethal laser. Here's what that looks like. She's not coming back. Yeah, it's okay, you can laugh. You can kill as many mosquitoes as you want. Not even PETA comes to save them. Here we vaporized her wing off. We had overdid it a little bit with too big of a laser and vaporized entire bugs for a while. It's very, very satisfying work if you can get it. I mean, I don't know what you guys are doing at work, but... So, whoops, that's subliminal marketing. Pass. Oh, you skipped that one. Okay, so my childhood in one slide. I grew up in the cold, in the dark, in the basement in Alaska with what's basically the first home computer. And this is, this is before the spreadsheet was invented. Like, this was not useful. You couldn't do anything with it except like crash it and reboot it. But, I learned a lot about computers. And I could imagine someday, it'll be faster, and someday it'll have more memory, and someday it'll be useful. And almost nobody was convinced. In fact, I had that thing, and I had a skateboard. and people were conflicted about which was a bigger waste of time for a kid. But Revenge of the Nerds, I was right. Eventually it got to be useful, and now we're going everywhere. And as an inventor, what I'm doing is cheating. I'm just looking around. Where are all the places that computers haven't gone yet? And see if I can get there first. This is a totally fake slide that I made up. Now, you can ignore this, but you've all spent plenty of time in Excel making a spreadsheet to spit out charts and graphs like this. This is what I call small data. You can just take Excel, drag it into the trash, empty the trash, tell your boss I said so. Nothing interesting will ever be done this way again. This is not what computers are for. This is just the best technology we've had. Now, we use giant supercomputers. You know, my whole life I wanted a faster computer, but I don't even care anymore. I got a fast enough computer. So do you. We can all rent giant supercomputers by the minute from Amazon. And the reason is we use them to do large-scale computational modeling. So a lot of times we're talking about these, new technologies, computational modeling, artificial intelligence, machine learning, neural networks, and that's just a bunch of jargon we made up to make ourselves sound really smart. You guys can actually understand this. And it's really important because these are the technologies that are giving us new superpowers to change the way we do everything. If you have a photo from your phone, well, a photo like that is a data structure. It's a computational model. The data is what color is every pixel, right? That's the same thing as a spreadsheet. What number is in every cell? That's all. Same thing. And then what's going to happen is we're going to run a filter to change the photo from color to black and white or increase the contrast or something, right? Well, that filter is an algorithm. An algorithm is a fancy word for a formula in a cell in a spreadsheet. You following me? Same thing. Only difference is the algorithm might be a little more complicated than the formula you would write in Excel. And then what happens is, in this context, I'm going to change that picture. So I have to look at a single pixel and then change its color a little bit. Now I got to compute what effect that has on the 8 pixels around it. And then I got to compute what happens to the 8 pixels around each of them. And I have this giant cascading exponential amount of computation to do. That's why it's hard. That's why computers couldn't do it for so long. But now, your kids are turning themselves into, bunny rabbits and unicorns with Snapchat filters because we have a surplus of computational ability, right? For the first time in human history. Our whole lives we've been computationally constrained. We're not anymore. We're imagination constrained. And our job is to figure out what are we going to do with these superpowers. A self-driving car is the same thing. It takes in images at 1,000 frames a second, and it's running giant algorithms on those frames, which are generated by neural networks, which basically is a fancy way of saying the computer randomly generated a bunch of algorithms and tested them all to find the one that works the best. But it's so much data, no human could ever parse it. And the algorithms are so complicated, no human could ever understand them. But it's easy for the computers. So that's my daughter. Okay, so here's an example of what we're doing with these capabilities. This is a blood sample of someone we want to test for malaria. And the historical way is you have a human technician counting cells in a microscope for like half an hour. It's like trying to find a marble in a football field, and you get a half hour to do it. It's that hard. Most humans aren't any good at it. Most countries are lucky to have one person who's good at it. And they go crazy after a few years from staring at dots. It's one of the hardest diagnostics. And we do 1 billion tests a year that way. It's not enough because with malaria, you have asymptomatic carriers. So people who have it don't know it. They're traveling around, spreading it to places we already got rid of it. So we would love to automate diagnostics, ramp that up, test people a lot more so we can treat them and really put a dent in the spread of the disease. So we invented this thing. It's an automated microscope. You take a pinprick of blood, it goes in there. It takes a half a gigapixel of photos, and then the computer goes and analyzes all those photos. It's looking at a spot like this, 7 microns across, and trying to guess, is that the malaria parasite in a red blood cell or some other crap in your blood? We don't know. This thing outperforms the best humans on Earth. Right? It's fast, it's cheap, we can make a lot of them. The team that did this figured out, as long as we're doing this, we could probably use this same technique to do other diagnostics. So they went after cervical cancer. So in the West, here, the best cervical cancer test is Pap smear, which is lots of fun. If you haven't tried it, go get one. No. It's the worst diagnostic ever, actually, 62% accurate. But since women go get it every year or so, we eventually figure out that you've got something we need to treat. And it works really well, actually, because we test so much. 80% of the women in the world will never get a test for cervical cancer of any kind. Well, we were able to adapt this thing. And just last month, the National Cancer Institute has confirmed our test is 92% accurate. Yeah, it's the best cervical cancer. And all you need is like a cell phone camera and a speculum and a buddy to do the test. It's actually, we can take it everywhere in the world. Okay. All right. So all this work is going on at the Intellectual Ventures Lab. That's the lab I started for Nathan Myhrvold and Bill Gates. And what happens is we tried to turn invention into a team sport and just do a lot of it and find ways to invest in invention. So invention is like the worst business in the world because you're just wrong almost all the time. So we literally have a batting average of 1. And what happens is, we'll come up with 1,000 inventions and hope that one of them pays for all the failures. It's a hits business, right? And the problem is lots of inventors. Do you know anybody whose business card says inventor on it? Besides me? It's not a legitimate career choice. You're not trying to get your kids to grow up and be inventors. And the reason is, if you're in your garage with crazy hair and a DeLorean, you get 2 or 3 inventions a year. It's not a winning business model. At our scale, we get enough of those hits that it works. And that's an important thing to understand. When you're doing new things, we like to think we're so smart. We're not so smart. I work with the smartest people in the world. They're not so smart. Nobody's smart enough to guess what's going to work in the future. The only thing we can do is come up with a lot of ideas and test them, run a lot of experiments and figure out what's going to work. And that's not just true for invention, it's true for you. A lot of businesses haven't figured out how to do that. So when you're an inventor, the inputs are, you need some problems, and you need science. So the output of basic research, that's scientific discovery, figuring out how the world works. The problems, you collect them. What are all the things humans do? Yeah, you need your garage with your DeLorean. And then at the other end, you have entrepreneurship. That's like taking an invention and making a business and a product and trying to scale it up. But that space in the middle is invention. There's usually a decade or so in there. It's poorly supported. But you have to go through all these different stages. And understanding that is really important because people are good at different parts of this, and people are supported in different ways at different stages along the way. So here's one of our hits. That stuff is kind of interesting. If you had a soup can full of depleted uranium that contains as much energy as 12 million US dollars of gas at the pump. That's how much energy you need for your whole lifetime. Pretty much all the energy you consume in your life could fit in that can, in uranium. But, you know, it's radioactive and dangerous and messy, and we don't know what to do with the waste, so we've been stockpiling it and saving it for our grandkids. So they're going to figure out, you know, how to make Legos out of it or something. We invented a new type of nuclear reactor that's powered by nuclear waste. What people don't realize, all the reactors we have today were essentially designed before we were born, with pencils and slide rules. And then we just stopped trying. Especially in the US, we got so politically unpopular with nuclear that we regulated it into oblivion. Nobody's invented any new reactor technology in our lifetime. The other thing people don't realize is today's reactors are 0.7% efficient. 99.3% of the energy is in the waste. So our reactors could get the rest of that energy out too. This is a stockpile in the US. 700,000 metric tons of depleted uranium left over from making bombs and making reactors. With this one stockpile, in the TerraPower reactors, we could power the entire planet, including growth, for about the next 1,000 years. You don't even need to mine uranium. We can do better on these things, but we've got to try. You know, that's carbon-free energy that, you know, essentially could be free. Okay. You guys sick and tired of hearing about these guys yet? I know I am. We think of them as tech companies, but what did Uber invent? You know, how many taxi companies could have made an iPhone app, but just didn't? You know, these are the poster children for disruption. So something interesting is going on here because they're making lots of money, or they're at least worth a lot of money. But I don't think that this is where technology comes from. Right? These are just the opportunists who manage to make a business out of it. And we really want to understand that because in every case, you have a couple of jerks from Silicon Valley who managed to replace an entire industry with a startup. That's pretty significant. And we want to understand how that works. When you have a successful institution of any description, could be a business, could be an industry, could be healthcare, democracy, or religion. In every case, part of what happens is you evolve an immune system. And the job of an immune system is to suppress risk. And if anything looks like risk, it's change. And that's why, where I come from, in Silicon Valley, we will not try to fix your business. We will not try to fix your industry. We're going to start from scratch, take all the superpowers we got from our computers, and make an end run around you, right? That's what happened in each of these cases, and there are more, right? It's a different way of thinking. Why would I fight the immune system? I'm going to start from scratch. We want to understand that process of disruption because it's affecting every industry in some way. All right? I'm not saying it's right, but we want to be honest about what we're up against if we're competing. So let's look at a roadmap of how this plays out. This is actually when you're disrupting, you play in the disruption game, you kind of want to start with the most screwed up industry you can find. So here's an example. 100 years ago, this is true for Canada as well, but in the US we would do, this is a yarn spinning factory, so that's how you make the yarn to knit or weave fabric to make your clothes. We don't do it in America anymore. We do it in Asia with a particulate filter. Almost no new technology. We don't sew in here anymore. We do it all in Asia with a particulate filter, but no other new technology. That sewing machine is better manufacturing tolerances, but basically no new technology. There's no computer chips in it, right? Same thing. This is an apparel factory in New York 100 years ago that burned to the ground. And then this is an apparel factory in Asia 6 years ago. So think about how your clothes are made. You grow cotton in one country, ship it somewhere else to be beaten down and bleached out, shipped somewhere else to be spun into yarn, shipped somewhere else to be knit or woven into fabrics, shipped somewhere else to be cut and sewn into t-shirts, and then you ship it back to America or Canada or Europe, screen print, team building exercise, 1999 on it, wear it 3 times, throw it in the bottom of your closet, that's $4. Think we could do better? I mean, this is an industry that's been built layers and layers of craft on top of each other over 100 years, and nobody can fix it. So, meanwhile, they act like you're a unique and special snowflake. You're just a small, medium, or large snowflake. In America, we print t-shirts for the winning teams and the losing teams. We sell half of them. The other half we ship off to South Africa and write it off as a charitable donation. They have a wildly skewed perspective on American football in South Africa. I don't know, can anybody tell me the last time this team won? This is like the 80s maybe? Yeah. If you're a fashion designer, things aren't better for you. You design something, you send it down the runway, you take some orders, you fax them off to China, you wait 6, 7, 8, 9 months for it to come back on a boat, you put it on the shelf, you hope you guessed right about what colors, what sizes, what designs, and the volumes. And nobody ever guesses right, so they all have battle scars from inventory management and guessing wrong. They're all guessing wrong. Last year, H&M burned $4.3 billion worth of clothes. Yeah. That's from guessing wrong. They're doing speculative manufacturing. Anyway, think about how we make software. So back in the 80s, the way we made software is you dream something up, you roll out of bed, you write some code for like 18 months, and then it goes on a floppy disk in a shrink-wrapped box at the App Store. Inside that box was a postcard where you could write bugs with a number 2 pencil and lick a stamp and mail them in to Microsoft or Apple or Adobe. We made software on the same 18-month product development cycle that we use for shoes and sunglasses and cars. That's not what we do anymore. Here's how we make software today. I dream something up, I roll out of bed, write code, launch it at lunchtime. That's your web apps, that's your mobile apps. All afternoon, people are emailing me, pissed off that it doesn't work on their Android phone. So I fix some bugs, launch another version, go to dinner. Fix some bugs, launch another version, go to bed. 4 or 5, 6 versions a day are normal. We've been doing that for 15 years. When we say software is eating the world, it's almost exclusively this dynamic. This rapid iteration makes us powerful. We act like kids in Silicon Valley are super smart. How smart do you gotta be if you're just gonna A/B test your way to success? You gotta be smart to guess a year in advance what your customer wants. We're just every one of you is running a different version of Facebook right now. Facebook has continuous deployment. There is no release cycle. Anybody working there can write a feature, launch it to 1,000 users. If it doesn't break, they get 100,000 users. If it doesn't break, you get 1 million. If that doesn't break, you get them all. We're testing you. And that has made us so powerful that software has taken over almost every other industry. And we're busy trying to figure out now, how do you make everything else the way that you make software? Go. I don't know what we got, low batteries or something. Okay. If we can make self-driving cars and we can make surgical robots, how long do you think it'll be before this exists? Come on. One more slide. Okay, watch this. What's missing in this video? Yeah. This is a prototype from Germany. It doesn't really exist. Everything you've ever worn was sewn by one of the tens of millions of factory dungeon workers in Asia sewing your clothes. But no miracles are required to make that thing work. If we can make self-driving cars, we can probably make self-driving sewing machines. It'll probably be just in the next few years when this type of thing starts to be possible and starts to get built. And you will see a sea change in a $2.4 trillion industry. Every human on Earth is a customer. And it's currently architected around chasing the cheapest labor on Earth. And when that happens, when that change comes, it's probably not going to be the incumbents who win. It's probably going to be two jerks from Silicon Valley who figure that out, right? So I wanted to play with these ideas, and I had been working on 3D printing. And 3D printing kind of gives you this sense that we could wire up the Buy Now button to the factory, not make anything until somebody clicks Buy Now, and make your stuff and ship it out the same day, and get rid of the inventory risk, and get rid of the speculative manufacturing. But 3D printers don't make anything anybody wants to buy. So I figured out I could do it with apparel. So this company makes clothes on demand. So watch this. This is a sort of old-fashioned artist. He's painting. He takes his design, puts it on the computer. Next thing you know, she's wearing it. The winners in the apparel industry, Forever 21, Zara, H&M, won by getting their supply chain tightened up so they could get their product cycle down from 9 months to 9 weeks. Well, this company got it down from 9 weeks to 9 hours, right? Because we don't make anything until you click Buy Now. Now they have 1,000 designs in 10 sizes, 10,000 SKUs, and if we order today, it'll get printed tonight and cut and sewn and shipped out tomorrow. I don't even have to go anymore. It's mostly automated. That's why I'm here hanging out with you guys. We can re-architect these industries, almost any industry. See if you can find yourself on this chart. We're going to make fun of Americans for a minute. If you're in the blue part or the red part, it doesn't really matter. If you're in the bottom 99%, in America anyway, you're still in the top 14% globally. On your worst day, lost your job, girlfriend left you, iPhone battery is dead. You're still in the top 14%. It's not so bad. It's like being a lottery winner. We won one lottery by getting to be human, which for a mammal is pretty good. Nothing coming after you except mosquitoes. Even then. Won another lottery by, growing up in, we'll call it North America. That's pretty good. But a lot of people are living like they have to win that next lottery. Right? We're over-optimizing for safety and security. What I think it means is the world just kind of over-invested in us. More money's been spent on me. More jet fuel's been spent on me. More education than I'd probably deserve. But I think it means we need to do what we're uniquely good for. Probably the world doesn't need me sewing in a factory. Hopefully I can find something more useful to contribute. If you have an iPhone in your pocket, the cost of that thing is equivalent to the global median income. Here's the punchline. Click. You click for me? Thanks. Okay. Anyway, I'm not trying to make you feel bad. I've got piles of these things, mostly with the screws taken out. You should drive a Tesla. You should have an iPhone. You should do all of these things with us. Waste a bunch of money on trying these new technologies. That's our role. And then figure out which ones work and understand, the job isn't done just because we made a product for rich people. Then figure out how to go solve some problem you don't have. Next slide, please. In Silicon Valley, we have this kind of religion called scratch an itch. Scratch an itch means find a problem you have and solve that, because probably your friends have it too. It's like budget market research. And this is why you have kids in San Francisco writing iPhone apps to have weed delivered to their dorm room. Because it's really the only problem they have left. Like, we're running out of problems. My problems are like iPhone battery doesn't last all day, and like relationship problems. No existential problems, you guys. I don't worry about malaria. And what I think it means is that, it's okay. Ship an iPhone app, make a product, but then learn from that. And then take on a problem that you don't have, that 1 billion people have. And take all this knowledge, our experience, and our resources, and solve a real problem. Here's an example. This woman is packing $25,000 worth of vaccines into a $2 styrofoam cooler. And she's going to truck them out into the bush, start injecting kids, and about half of those vaccinations are going to fail. And they fail because they didn't stay cold. And we just inject kids anyway. 250,000 kids a year die of something they were vaccinated against. That's a pretty big failure. That's lives we could save. We don't have this problem because we have refrigerators and power. The power is out 4 to 16 hours a day in these places. So we invented this thing. It's a kind of super thermos. You take vaccines, put them in there, stick it in the sunshine, in the Sahara. There's no external power. It doesn't have a power cord. But you come back a couple months later, and your vaccines will still be cold. We can do better on these things, but we've got to try. I keep thinking if I hold this over here, it'll work. Okay, oops, back up. One, back up. Yeah, this is literally the deployment scenario. You strap this R2-D2 looking thing to a camel, walk for days into rural Ethiopia, set up a clinic, which is a big word for like a tree with a doctor under it, and this thing. This is the front lines of vaccination. This is how we save 1 million lives a year or more. That styrofoam cooler is good for 4 hours. That's what we've been using today. So I'm going to stop here. We have a little bit of time to take questions. And I know that we have some of the questions in Slido. If you guys want, you can send them in Slido. And then we have this. This is one of my favorite things ever. It's a microphone in a stuffed animal shaped like a box. And you hold it up against your chest, and then you can ask questions. And then you get to throw it at your friends. So anybody have a question? It's okay, I'm friendly. I'm going to be nice. Okay, back here. So pass this back to her. Yeah, okay, cool. And then I'll put this down.
Hi. If you're more of an ideas person and not like a techie, or once you have the idea, how do you execute that idea?
Yeah,
Where do you find your resources?
Yeah, I mean, I think one of the most important things to do is going back to that slide I showed that shows, it starts with discovery. Invention is that, that's the ideas part in the middle where you take I'm filling my head full of like every scientific discovery, every new algorithm, every new chip, every new sensor, all those things are my toolkit. And then problems on the other side. There's a Rubik's Cube in there that matches them up sometimes. When you're that person, I think a lot of times what's slowing us down is essentially lack of teamwork. Right? You've got to find the people who are good at the part you suck at, right? So in Silicon Valley, we screw this up all the time because we take the inventor and try and turn him into an entrepreneur. Well, let me tell you, that's not usually a winning strategy. That's not what these people are good for. So we also have the worst problem is the opposite. We have entrepreneurs who make a business out of something, whatever they could invent. And so we have this kind of crappy product or service, but with great sales and marketing or something, right? And what we need to do is separate those roles, figure out who can come up with the best ideas, and then filter through them and find the best ideas. And I think a lot of it is about like I said, for us running experiments, right? None of us are smart enough to know what the best ideas are. And that's like why this industry is really interesting because, I don't know about you guys, I go to a lot of meetings like this. And, we have a lot of things we've figured out over decades. We have a formula, we have a system down. You know what? The system doesn't involve banging tubes together. That's an experiment. We got to try that and find out, is this a way that's going to work to make the meeting better, to make our experience better? You look at industries like retail. Retail is just dying fast. Like nobody wants to go to a mall anymore, and a lot has been invested in that. And so the winners in retail are the ones who managed to figure out. They ran experiments and they figured out how to change the dynamic into an experience, right? That's kind of analogous to, I think, what's going on in this industry. We can't just throw people in a room with a stage and a microphone anymore. We have to make it more of an experience. And none of us knows what's going to work. It's a moving target. So what's cool, I think, about a group like this is, look, we got 300 people. If every one of you went back and ran an experiment, we'd have real good odds at finding something that made things better, right? And until we try them, we won't know. And a lot of times you got to try them multiple times in different ways, from different angles and in different places with different people until you figure out. I mean, she's running an experiment with Slido right now. We're going to find out if that works. Can that make the meeting better? Maybe it's going to make it a little better, maybe it's not, and then next time she's going to come back with a different version until she steers to what works. Okay, I'm going to read some questions here. How easy is it to circumvent the product of today and disrupt when you are part of the product today? Okay, I'm going to be honest, because you guys get to kick me out of town after this. I don't really believe in that because I don't see a lot of success stories, right? In America, in the 80s, every big American company had a R&D department whose job was to invent the next technology, next set of products for the company. They kept getting their butts kicked by two guys in a garage. So we shut down R&D, but we replaced it with M&A, right? So that's an example of how big companies learned to have a relationship with innovation and recognize we're not built for innovation, right? We're not built to hire Sammy and let him do crazy stuff, right? You don't hire CEOs to do some crazy experiments. You hire them to do exactly what happened last year, a little bit faster, a little bit cheaper, a little more profitably. That's not the profile of an innovator. Why would you try and turn those people into innovators? I don't think it works very well. There are certainly cases where, big companies tend to be good at incremental innovation, right? So for example, I wouldn't try to invent a better inkjet printer, but I might try to invent what comes after inkjet. I know Hewlett-Packard is going to figure out how to make a somewhat better inkjet printer, probably forever, right? So that's just understanding what you're good at, play to your strengths, and then figure out how to party with the people who are not like you. That's how I think about it. I think we've wasted a lot of time and money and energy on trying to get big companies to be more innovative, right? All you can do is try and make your company less hostile to innovation, right? You need to, if you're in a position to get a machete and clear a path for the people who have the new ideas so that they can run those experiments, then you can make a difference. Otherwise, you want to find some, one way or another to have some context where you have that relationship with innovation. Anything this radical and forward-thinking you are seeing in the conferences and meeting industry? Well, here's the thing. That's why I use the retail example, right? This is, going to, you're safe, right? This is not an industry that's going to be replaced by some iPhone app, okay? As much as we're going to try to make virtual reality meetings and stuff, the truth is there's something really important and special that happens when you get a bunch of people together. And it's not me being on stage talking at you, right? I'm just a way to get everybody to show up in the room at the same time. After me, you guys are going to hang out, you're going to have lunch, you're going to get to know each other, you're going to talk about what worked in your business and didn't work there, and probably like get hired by the other guy, those kinds of things, right? That's the important stuff. That's relationships. And we all know that because you guys work in this industry. The real meat of this is that something special happens when you get people together. So we're going to keep doing that, and I think the demand for that is probably, I don't know what you guys feel about your industry, but probably increasing because people are spending so much time doing things that are not like that, right? We spend a lot of time in a context that is not fulfilling in the way that being with people is. So I think there's a lot that's good about this industry, but we do have these patterns, right? We do. I mean, this is actually a really interesting conference because they are trying different things and trying some experiments here. I think you need to ramp that up, right? Find a context in your company where you can run some experiments. Find a context across the industry where you can run a lot of experiments, share the results, and advance the industry. Can we throw the microphone back here?
Hi, so
Yeah.
I have a question.
Yeah.
You spoke about Silicon Valley and the VCs. If you were a VC today and you had to take charge of where money's going, because money's being thrown around everywhere,
Yeah.
would you have a software or would you have an algorithm that would bet on where things are going? Because today it's just billions.
Yeah, wow, you're stepping in it because I'm opinionated about this one.
I know, I figured.
I think, look, I think Silicon Valley really lost its way. I come from like the Silicon Valley of the 80s, when the job there was find a technology and use it to create something people didn't know they wanted, right? Create a market and adapt that technology, find a way to bring it into the world. Everything going on in Silicon Valley now, as far as I can tell, is just iPhone apps, right? I didn't show you any iPhone apps, right? We're inventing new technologies, and those all need an entrepreneur. They all need, somebody to turn it into a business, and I got thousands more, right? But that's not what venture capital is really doing anymore. I think they've really lost their way. They've co-opted the model of venture capital to fund a bunch of Shark Tank-esque crap that it's infomercial products. I mean, I don't really know what the point is anymore. But yeah, so if I were a VC, I would probably do my best to avoid that stuff. In Europe, they kind of started calling it deep tech. Deep tech meant things that were not software apps, and I think now they mostly just means hardware. But if you have deep tech, then all the other stuff I think of as like shallow tech, right? And I don't do shallow tech. And so if I were you or if I were any VC, I would be trying to look at, I mean, there's good businesses in software, but.
But at the end of the day, Bill Gates, who you could have said was shallow tech, made billions to give you money to create the science that is needed. So money has to come from somewhere.
Yeah, that's certainly true. I'm saying there are good businesses.
You know, you have to look at it at maybe a larger
Yeah,
scope. But
I think, I mean, I could sort of nitpick about that. I never worked for Microsoft, and certainly there's lots of ways to like vilify the history of the software industry. Even software in those days was a new technology that did need to be brought into the world. That's not really true anymore. Now it's just taking it and adapting it to different businesses and industries. It needs to get done. I'm not arguing with that, but I don't think that that's where you get the force multiplier. When you invent a new technology and bring it into the world, you get an exponent, in your equation that allows you to solve a problem at a bigger scale. When that first slide I showed, population growth, if we're going to solve problems on an exponential scale, we're going to need new superpowers, and those come from inventing new technologies, and I don't see that happening in software too much. So that's why I say that. Any last question? Yeah. Oh, can we throw the microphone over here?
Yep.
This is part of the fun. Yep. What? Who plays rugby here? No.
Where's it going?
One there. Got it? Oh, good work.
The companies you've mentioned so far, I think of as enriching their owners more than anybody's wildest dreams. And it had been the turn of the century would have said it was like Standard Oil and would have vilified them. Right now we think Google is just amazing and Microsoft's just amazing. And so I guess my question to you is, how do you move this down so
Yeah.
there's a genuine positive effect on others?
Yeah.
Because what we see so far is extraordinary enrichment of some.
Yeah, I mean, we
And by
certainly.
the way, that is not meant to be a political comment,
Yeah.
please.
Well, we have a problem certainly with this kind of, I mean, I guess we call it inequality these days. There's probably no real end in sight. We've had inequality on a global scale for a real long time. And the truth is, as even though the inequality gap, it seems to be rising in a lot of places, every day we bring hundreds of thousands of people out of extreme poverty, right?
Where?
All over the world, and mostly south of the equator, so that's Africa, Southeast Asia, Latin America, China. And that's an extraordinary and amazing thing that humans have accomplished. We're not celebrating those things because we're pissed off that the neighbors have BMWs while we still have Priuses and that kind of stuff. But the truth is, humans are doing a lot of amazing things that we're not really paying attention to. The truth is, though, that's possible because of the technology, and it's possible even Google, even Microsoft, Amazon, all those things that we're spending lots of money on, we're making a bunch of rich assholes on the West Coast, I know. But the truth is, a lot of that stuff everybody gets. I mean, almost everybody on Earth that wants one has a cell phone now. In the next few years, it'll be a smartphone. You know, when you get a smartphone, you get Wikipedia for free. You get Google for free. I mean, I pay for Google. I don't know, remember you guys writing a check to Google? Anybody remember? They're making money off of us because of ads. They're not making money off of anybody else, you know, south of the equator. But we subsidize that. We're paying for that. And what's cool about it is democratizing in that sense. Like, we are getting these technologies to the whole world over time. We'd love to have it happen faster. We'd love it to be more fair. We definitely want it to be, you know, more egalitarian. But all these technologies we create, they do help everybody eventually. It just, you know, it takes time. And what's really interesting is, you know, it used to take hundreds of years to spread across the world. Now it's taken decades, and we're frustrated that it takes so long. But we're getting that down. And I think, you know, what's amazing is, you know, I'm so excited about what's coming soon, because we're going to get another billion people in the world on smartphones. That means another billion people online. And that means they get to participate in the global economy. They can help themselves with all the... I mean, when I was growing, the way I learned to program that computer was it was like reverse engineering 6502 assembly language. That means I had to like find a 1 or a 0, change it, see if it crashed my computer, and then figure out why. Like, it was painstaking. There was nobody to teach me. My kid watches YouTube videos. She learns a lot just from, I mean, you can learn almost anything on YouTube these days, and the whole world's about to get that for free. So I think, you know, there are certainly lots of problems and lots of things we need to do better on, but man, the acceleration of our ability to bring these technologies to people and make an improvement in their life is astounding, and I think we should at least take some credit for that. And then probably go back and figure out, you know, how do we get more bang for our buck out of, you know, assholes on the West Coast. So anyway, and that might be me too. Anyway, thanks you guys. I'm going to hang around so we can... Yeah.